Namaskar my dear friends. Let's talk about LTSpice Simulation. In this schematic demonstration, we will try to understand what is parametric sweep. So we will try to understand with two examples. One will be with voltage source, another will be with current source. And as you can see in parametric sweep, let us say we have a value of R2 which is X. Okay. So either we can vary this value to, let's say, 1 kilo ohm, 2 kilo ohm, 3 kilo ohm. So as you can see, based on the variation of this R2 value, there will be different voltage appearing at the V out node, right? So as my R2 is increasing, my V out will be decreasing. So you can see for 3 kilo ohm, like this is 3 kilo ohm, so output voltage is 2.5, and for 2 kilo ohm output voltage is 3, and for 1 kilo ohm output voltage is 3.75. Understood? So the parametric sweep actually gives you an understanding, or gives you a like control of varying a particular value or maybe multiple values as well, and you can simulate the circuit in a single shot, right? So let's try to understand how we can assign parametric sweep or parametric values to a particular component in a different fashion. As we have already seen, suppose we want to give a single value variable, then let us say R1 is R1 is the value which is having a variable X, and if you want to have a single value for that, we will put a spice directive as dot param X equal to 10 kilo ohm, or otherwise 20 kilo ohm, 30 kilo ohm, or 10 ohm, whatever the value you want, you can put the particular value for a single values. Coming back to the multiple values, so multiple values we have a command dot step. Okay. So let us say we want to vary the variable value X from 10 kilo ohm to 30 kilo ohm in a step of 5 kilo ohm. So what will be the different values that will be assigned? It will be dot step param X, and then 10k, 30k, that is a start value and a stop value, and this is the step size. So what will be the values that will be assigned to my R1? That will be coming as 10 kilo ohm, and then 15 kilo ohm, 20 kilo ohm, 25 kilo ohm, 30 kilo ohm. So this is how you will be assigning a linear variation of a particular variable. Coming back to, have sometimes we need only random values. Let's say we want some 2-3 values which is specific to you. So in that case we have to just insert one list command. Okay, so that is dot step param X, and that will be list. So this X is the variable that you have assigned. Okay, it can vary. Let's say you are putting Rx, Ry, Rz, so whatever the value that you are putting in the variable, that name should appear here. Okay, and then for random values we will put it list, and then let's say only 3 values we have to assign: 10k, 20k, 30k. So these are the values that will be assigned to the variable R1. Okay, so analog devices has actually given like step parameters. So for linear growth we have a dot stepped elements that we have to give. What is the start value, what is the step value, what is the increment or step size. If you have to give like random values, then you utilize list, and in this list we will have a step element and then list value 1, value 2, value n. Okay, in the same manner we will be utilizing decade, octave, all these things in our like basically frequency analysis. Okay, so I'm not telling you that one right now. All right, so let's proceed that. We'll see this particular circuit with one voltage source, and we'll try to change this one as current source, and then we'll see the different output. So let's open LTSpice. I'll just remove this circuit and let's open a new circuit. Okay, so what we can do is we can quickly create one small circuit which will be like with voltage source. So let's put V for voltage source, and then G for one ground we'll need, and let us say we'll need 2 resistors. So one will be R1, and let's say I'll just rotate it and put it R2. Now we'll quickly wire this. So by pressing W you can get the wire. If you are using the new version of LTSpice, they are very user friendly because they have a lot of good shortcuts now. Done. Now what we'll do is we'll just right click and put let's say I want a value to the variable source as 5 volt, and let's say I want this resistance value to be varying as, let's say, Rx. Okay, and I want this particular value to be 3 kilo ohm. Okay, So if you run this, you will get errors. Why? I'll just tell you. Let's say I'll just put it as 10 millisecond and start saving data from 0 itself, like beginning itself. So see, it cannot find the value of model Rx. That's the reason it is giving you error. So R2 value was not defined, and if you want, you can have this particular error log always, so that you have a proper understanding now itself, and later on in big circuits you will be able to analyze this particular understanding. Understood? So the R2 value, which is Rx, which is unable to find the definition of model Rx. Understood? This is the reason this value is not coming. So what is our aim? What we'll do is we'll just put .t, which is spice directive. So spice directive, and let us say we want the value to vary from 5 kilo ohm to 20 kilo ohm, or let's say 1 kilo ohm to 3 kilo ohm, right? So dot step, then param, and what is the variable value? That is Rx. Now let us say I want this value to vary from 1 kilo ohm to, let us say, 3 kilo ohm in a step of 1 kilo ohm. So what is the start point is 1k, end point is 3k, and step value is 1k. So this is how it will appear. Got it? Now if you run, Rx value will be assigned 3 values, 1 kilo ohm and 2 kilo ohm and 3 kilo ohm in step of 1. That's why it is coming. So let's let me give the like net name also. It will be easy for visualization. Okay, so this is my V in. So this is my V in, and let's say this is my, I'll put Vx. Okay. Right click and change the name of Vx. Now let's run this. We are ready to run. So this is my input voltage. As you can see, this is my 5 volt. Now if I put Vx, there are 3 values that is appearing. Vx, which is let me just change the scale. Start from, let's say, 0, and I want to go with 5 volt in a step of, let us say, like 0.5 volt. Okay, so you can see we have 3 values. One is 2.5, one is 3, and one is around 3.75. Okay, now you do not know for what value of resistance edge which is the curve, right? So if you want those legends like different colors for these 3 values, only click this one double time, so you will have these 3. So let me just start from 0. It gives you a better understanding. 0.25 if I want, and I'll just make it 5 volt. Okay, so we have 2.5, we have 3, and we have 3.75 volt for 3 different values. Okay, now let us say we want to see what is the corresponding value of R2 for which voltage is. Then right click it and go to there is something called as, wait a moment. So what we can do is, in this particular waveform window, we can right click it, and there are various options. Okay, so we have to have the legends for each of the resistor values corresponding to that voltage we want to see. So go to notes and annotation. In this notes and annotation, you will see there is annotated steps. So if you see annotated step, it is coming, so you can go and place it. So as you can see, this color is Rx equal to 1 kilo ohm. So as my Rx value is increasing, my voltage value is decreasing. That you can very easily see. Understood? So that's all. This is with like parametric sweep. If you want, you can have other values as well. Let us say we wanted to have linear variation. Let's say I just go here, this parametric sweep, right click, then it will open this particular window, and let's say I want to make it 10 kilo ohm and go to 30 kilo ohm in a step of, let's say, 5 kilo ohm. So we'll have around 5 values. Okay, now let us say I'll just make this as 5 kilo ohm, so it will be easy. Now if you rerun it, there will be 5 values that will be appearing. Okay, just change the scale to, let us say, like 5 volt. It will be easy to view, and let's say 0. Like 2 volt or something. Okay, so from 0 to 2.5 5 volt I have made it, and you can see the values are appearing like this. Okay, I'll just annotate again, notes and annotation, annotate the step, and you can see these are the 5 values. If you want, already there was some like annotations, I can delete that. Okay. So see, we have 10 kilo ohm, 15 kilo ohm, 20 kilo ohm, 25 kilo ohm and 30 kilo ohm. As my Rx value is increasing, my voltage value is decreasing. Understood? Let me just change this particular value to another thing. Just go this particular value, right click it, and I don't want a linear variation. I want only particular values that I want it. Okay, so let us say I just want two values. So what I'll do is dot step parameter, and then I'll put Rx then list, and let's say I want 1 kilo ohm and I want 5 kilo ohm. Okay, so only two values I want. So what will happen? This Rx value will be given 1 kilo ohm and 5 kilo ohm. So for 1 kilo ohm it will be having a low value, and for 5 kilo ohm it will be having higher value. So let's rerun it. I'll just remove this. I'll just go zoom to fit. Rerun it. So you can see only two values are appearing because Rx was 1 kilo ohm and 5 kilo ohm. As you can see, for 5 kilo ohm the value will be half, that will be Vx is 2.5. Understood? And for 1 kilo ohm the value will be quite high because only 20% is being dropped. Same design you can do with let us say current source or something like that. So let's quickly do that as well. Just open a new window and put a current source. So how do we do that? Go to components, put a current source, and this is appearing at towards below. Okay, so what we'll do is control R to make it above. Put a ground source, let's say I'll just put it here, and then put two resistors. I'll just put two resistors. If you want you can put whatever way you want, like two resistor, three resistor, something like that. Let's quickly rewire them. So I'm going to rewire them like this. So we have a like current division methods, and what we'll do is we'll try to vary one of the resistance value. So let us say R1 I'll just fix it at 5 kilo ohm, and R2 I will vary it with, let's say, Rx value. Okay, so this is wrong. Both sides should be curly braces. Okay, Rx. Let's say I'm going to define this particular current I1 as let's say 10 milliampere. Okay, so 10 milliampere is the current. If the value of R1 and R2 both are 5k 5k, then the current flowing through each one of them will be 5 milliohms 5 milliohms. So what I'll do, what is the first step? Just go and put a spice directive for this Rx value, right? So what we'll do is put a spice directive as dot step, then what was that? Param Rx. Let us put a list value, like we want only two or three values. So list, and what I want is let me just give an understanding like 1 kilo ohm and let us say 5 kilo ohm. Okay, so only two values I want it to appear. So these two values has appeared. Now if you run it, this is the run button. Okay, so if you run it, it is asking for a stop time. So let me run this for let's say 2 millisecond, and I want the data to start saving from 0 itself, like beginning itself. Okay, so I'll just remove this voltage circuit. Okay, let me make it little bigger and run it again. Okay, so as you can see we have the voltage at this point, which will be how much? Let me just show it. Voltage at node 1 is appearing to be how much? Two values are appearing. Why? Because there is a two value of resistances. So this is bit confusing. What I'll do is I'll just find the current so that you will understand what is the current flowing through my circuit. So let's say I'll just double click on this. What is happening? The current flowing through this I1 is 10 milliampere, that you are able to see. What is the current flowing through R1? That will be two values. You can see the green color, which is IR1. So that is two value. Why? Because we have R1 R2 as 1 kilo ohm. For that R1 will be having different current, and R2 is 5 kilo ohm. For that IR1 will be having different current. So if you want to see both of them in different colors, then you can go and click different colors, and I'll just right click it. Since it is like more than 1 ampere and this is less than 5 amperes, so what I'll do is I'll start from 0 and go up to let us say 6 milliampere. Okay, and let's say I'll just go in a step of 0.5 milliampere. So you are able to see very properly what is the current through R1, right? If you want, you can put a legend as well. So what we'll do, go to right click, notation, and annotate steps, and you can see when Rx was 1 kilo ohm, my Rx was 1 kilo ohm, the current through R1 will be lesser. When Rx is 5 kilo ohm, that is value is higher, my current through R1 will be higher. So you can see this is 5 milliampere, like both are same. Similar to that, if you want, you can press like a current through R2 as well. So just double click or double click it, so only IR2 will appear, and this is how you will be able to find it out. And if you want, quickly go ahead, right click and go to notes and annotation, annotate a step, and you will see for Rx equal to 1 kilo ohm my current is high, and Rx equal to 5 kilo ohm my current is low. So this is the like very powerful tool or powerful technique to vary your variables in a different manner and see the simulation in a particular single window. So hope you have a good understanding about parametric sweep and parametric analysis of different circuits. And if you do have any questions or any queries regarding this, you please put down your queries in the comment box, and we shall be able to answer you out very properly. So always, if you want to see the left side very properly, what is the ticks and all, try to go ahead and change the ticks. So you can start from 0 milliampere to that one, and then let's say tick I want 0.5 milliampere. So you can see it has started from 0, very easy, and this was additional values, I can just delete them. So for Rx equal to 1k, Rx equal to 5k, these are the two different values, 5 milliampere and around 8.4 milliampere or something like that. Okay, thank you.